Welcome to the fourth Motion Layout MAD series video. In this video, you'll learn how to build a collapsible toolbar using Motion Layout. Now, this is a classic place to use Motion Layout, as it allows you to build rich animations with almost no constraints on your design. Along the way, we'll take a look at how to drive a custom attribute using Motion Layout. Now, if you're new to Motion Layout, be sure to check out the previous episodes first to learn the basics. I've already created a screen with Motion Layout inside a coordinator layout. There's two constraint sets with some constraints and keyframes already set. The first thing to note when making a collapsible header with Motion Layout is to put the Motion Layout inside an app bar layout that has a fixed height. Then, set the collapsed height as the min height on the Motion Layout child. Now, when building a collapsed header with Motion Layout, it does behave in a strange way. We want to keep the Motion Layout a fixed height using match parent. If we click the Motion Layout to show the motion editor, you can see that it uses the full space in expanded mode, but in collapsed mode, it actually draws in just the bottom region of the Motion Layout. Let's switch to the blueprint and see how to handle this. A good strategy is to use a guideline. That's a fixed horizontal or vertical line in a constraint layout that you can constrain other views to. Here, we've created a collapsed top guideline that everything is constrained inside when the Motion Layout is collapsed. If you've used guidelines before, you're probably used to fixed positions. For example, 100 dp from the top or 50%. You can also set them in code, which we can use for insets like camera cutouts. We'll define another guideline for the system inset that we'll use in this animation, and we'll just give it a default value of 80 dp in XML, so that way the preview can display it correctly. The other guideline in this layout is used for the animation itself. Expanded bottom is the visual bottom of the background when we're in expanded mode. This gives us some area to paint the oversized emoji in below the apparent visual bottom of the header. And this makes it look like we're drawing outside the view. To drive the Motion Layout as a collapsible header, we need to write some code in the activity. In the app bar layout, the on-offset change listener will inform us every time the collapsing toolbar should change its collapsed progress. With a bit of math, we can convert the coordinates that it provides into a range between 0f and 1f that Motion Layout needs. Then we can tell Motion Layout about the new progress, jumping right to the value. This will be called every time the user scrolls, so they'll see the animation play one frame at a time. These lines are the real trick to integrating Motion Layout as a collapsible toolbar. In this animation, we also need to know the insets to make sure we don't draw anything important under the camera cutout. To make that work, we're going to dynamically change the guidelines to the insets for this screen at runtime. First, we have to grab the desired collapsed height of the toolbar. We want to try to end up with this much height after the inset is applied. Then, we add an inset listener to read the system window inset top and find out how much we should allow the system window area. Update the Motion Layout to allow for the new inset area in its collapsed height by updating min height. And finally, set the guidelines. In Motion Layout, you can modify the guidelines of any constraint set in code by reading the constraint set. Here, we're reading the collapsed constraint set and calling setGuideline to update the guideline. The idea is the collapsed top will point to the top of the screen, and inset will always point to the bottom of the inset region. We can do the same thing for the expanded guideline. By setting the inset here, the guideline will animate from expanded to collapsed in the correct position the entire time. That's a bit of code to set up, but it will give us the two guidelines we need to build our animation. Before we switch back to the animation, I want to briefly scroll down and show you that our background is using a custom image view subclass that defines three new properties that we can animate via getters and setters. Bottom cut, end cut, and it also defines a property translation progress for efficiently translating the background image using a matrix. Let's hop back to the motion editor and take a look at using these properties from Motion Layout. Selecting the expanded constraint set, I can create a custom attribute to constrain these custom properties. Select background, then scroll down to custom attributes. I've already defined translation progress since it's needed to make preview work. Let's add bottom cut and end cut. In the expanded state, we want bottom cut to be 120 dp and end cut to be 0. Click the plus button and add a new custom attribute. Custom attributes can be any of these types, and the only requirement is that the object exposes a getter and a setter. For bottom cut, we want to specify a dimension. Specify the value you want in dp or with a dimension resource. For this animation, we want 120 dp. The autocomplete box will show you all of the properties that motion layout can animate and allow you to autocomplete dimensions. And do the same for end cut size. We want to specify an end cut of 0 dp in the expanded state. Again, click the plus button, select dimension, pick the property, specifying dimension in dp. We'll do the same thing for collapsed constraint sets, though we'll skip the dialog with a magic cut. 1, 2, and done. Before we preview it, let's add a few keyframes to finish the animation. Select the transition and click on the Create button on the top right, and select Key Attribute. This will let us modify any attribute during the animation. We want to hide the bottom cut a bit early, so with the background view selected, add a key attribute at frame position 60. Scrolling to the bottom of the list, custom attributes are listed. Select Custom Bottom Cut. Click on the diamond for the new key attribute and set the end cut size to 0 dp at frame position 60. And to make end cut overshoot a bit, we'll add another key attribute at position 80 and make it oversized to 220 dp. I'll do this one with a magic cut, and done. And if we play back the animation now, you can see that we're animating the custom properties on our custom view with motion layout. The circle cuts are completely controlled by motion layout, calling setters on my custom view. There's one more step to finish this animation. We want the emoji to jump instead of move. You may have noticed motion layout loves to make straight lines and smooth curves. In fact, it had to solve a lot of really fun calculus problems to make all of that work efficiently. However, sometimes you just want things to move in ways that motion layout didn't anticipate. Let's take a look at one way to do it. We're going to make two key positions, one frame position apart, and tell motion layout to complete the entire motion in that one frame position. Let's get started by creating a new key position at frame position 35 on icon. Set the path to delta relative, that is relative to the path it was going to take already, and set both the x and the y to 0. This will cause the icon to not move for the first 35 frames. And do the exact same thing at frame position 36, but this time we'll set x and y to 1, which is all the way along the path. That means between frame position 35 and 36, motion layout will move the view completely along its path. Since we also made the view invisible for this frame in another keyframe, it will appear to pop to the user. This almost works, but if you look really closely, you'll notice the motion right before the view disappears. And this is because motion layout is trying to smooth the curve. It's anticipating the fast motion before frame position 35. To fix that, select the key position at frame 35 and add an attribute curve fit set to linear. This tells motion layout to calculate straight lines instead of curves, and do the same thing for frame position 36. If we play the animation again, we'll see the icon appears to pop out without moving, then pops back in at its final position. By using the linear curve fit, motion layout doesn't anticipate the fast movement between 35 and 36. And that wraps up the Motion Layout Mad Skills series. Thanks for watching. I can't wait to see the animations you build in your apps. To learn more about motion layout, check out the code lab and motion layout integration samples that these videos were based on in the links below.